So in our last module, we discussed about a brief introduction about reinforced concrete design. So in this module, we are going to discuss about the different types of load that acts on the structure, the structural load part or transmission mechanism, and some major structural systems when it comes to construction. So now first, load and action in structure. Every structure is made up of Every structure is made up of structural elements. Okay, we have the likes of beams, columns, slab, etc. And also the structure is also made up of non-structural elements. So these two elements are present in every structure. You understand? And some of the non-structural elements are the ceilings, the partitions, the doors, etc. Then you may ask me, oh, what's an action? An action is just like a force is applied or imposed on the structure. This force can be permanent or temporary, or as the case may be, transient. Now look at this diagram here. It's showing someone um, adding a force to the wall, and the wall is giving a reaction as a permanent. Since the wall is a permanent load, there's a reaction that is coming from the opposite side of the structure. So these two elements must be present in every structure. Understand? So in this case, the wall is acting as a permanent um, load, while the person is acting as an imposed load. So let's go deep. Now, the types of loading, or you can call it types of action. You have permanent actions. Okay, this category of load include the weight of the structure, that is the self weight like the concrete unit weight and all, and permanent materials used on the structure during construction. Some of these permanent loads or forces or material, we have ties, we have walls, beams, columns, roof load, etc. They can also be called dead load. Now, permanent action is a uh, is a notation used in Euro code if you are designing structures. So anywhere you see actions, they're actually talking about loads. Okay. Then we also have variable actions. This category of load is referred to as live or transient load. There is load that are movable and unsteady. They are frequent. They come and go, come and go. It's not like the one of the permanent load where as once it's erected, it does not move from its position. So some of the examples of such load are the composite load under variable action. Composite load is talking about maybe dwellings, people, etc. Weight of traffic on the bridge, and they're also called imposed or live load. Now let's go to the next slide. We also have another type of loading known as environmental actions. This category of loads, they are due to nature, that is the location of the structure. Look, when we talk about nature, we're talking about the environment itself. Examples of such actions or load are snow load, wind load, seismic load, earthquake load, dynamic seismic load, earthquake load. These are natural occurring loads that must also be factored while designing any structure in ROCC. Now, they are also classified as live load, but the source of the action is from the environment. Now, let's talk about structural load transmission and structural load transmission mechanism. Basically, structural load transmission systems are categorized into two, that is the direction of flow and in which load is acting or be transferred. Now, gravity load, let's take a look at a story building or a building with the first floor. Now from the first floor we are going to have a slab at the first floor. Now this slab is going to, those on the first floor, let's say there are machineries on the first floor. Those machineries on the first floor, they are going to act vertically. The forces are going to be transferred vertically to the substructure, which is the foundation, then to the soil. Now at that stage, the machineries are acting as gravity load, acting directly on the slab, from the slab to the beam, then from the beam to the columns, then to the foundation. Now you can also take a scenario of roof loads, life load, and also other dead loads. So those are gravity loads. Anytime talk about gravity load, we're talking about vertical loads on any structure. Then the lateral load, these are the environmental loads or any load that is acting in the horizontal direction of the structure. These include wind forces, earthquake forces, or load as the case may be. Then let's talk about structural systems. In all we do, there are different structural systems in terms of any design you're doing. It can either be a frame structure, it can either be a load bearing wall structure. Now in a frame structure, the frame structure is kind of a bit flexible because you can actually dismantle and reassemble them. It's unlike the load, what's it called, the wall load bearing structure. Now let's go deep. Frame structure is a structure that is interconnected by different structural elements, which then helps to transmit loads to the soil. Examples of such elements are the beams, columns, slab, foundation, etc. Under the category of frame structure, we have different types of materials that can be used. Okay, we have the truss systems. This also, like if you have seen bridges where we have kind of ions, using the local language ions, or but they are actually steel. You see them just by the side of the bridge. Most of them are truss systems. Our gates, doors, most doors these days are truss systems. We have timber structures, we have steel structures, we have portal frame structures, shear structures. Shear structures, you can take a look at domes, those big buildings that are in kind of spherical shapes. We have RC structures, which are reinforced concrete structures. All of these are categorized as framed structures. Then lastly, we have the load bearing structure. The load bearing wall system is a simple traditional system where walls support and transfer the building's weight, roof, floors, and all to the foundation. This is commonly used in houses and low-rise buildings such as say bungalows and all of that. So with this, we have been able to complete the second module of this course, and in the next module, we are going to discuss about loading analysis systems in reinforced concrete design. Okay, thank you so much, and sure to subscribe for more videos.